100 meg, 100 meg, that's fine. Okay, so the only reason I'm actually testing that is because usually I would use my own lead, but it unusually came with a lead. Let's take a quick look around the back. So the usual power socket. Over here we've got a 15-pin data socket. So this enables us to, instead of using these to provide data from the outside, it should be able to do a bit of configuration instead of using all these buttons to configure everything, configure through that port. And also secondly, this feed for this paper that moves it forward can be controlled by a pulse that comes in. So if you have something that works intermittently or at variable speed, this paper can change speed to synchronize with it. Okay, we'll just give it a basic run for the minute with nothing connected at all. In fact, if they're in here, yes it is. I'll just connect the positives to the negatives just to make sure it's at 0 volts. Okay, cool. Right, power switch on the left. So far so good. So that's come on. The pen to point with. The sort of pen holder just in here has moved across to the 0% line and looks pretty well lined up. Yeah, and as I move this dial, it is responding, which means that the servo motor that controls that must be working. Let's turn this onto a... Yeah, it's got a little bit of an offset going as we move this button. Not a lot. In fact, it's only on that bottom reading. It's moved about, I would say, about half of one of these small divisions on the paper. Not bad. I'm going to set this to a fairly big voltage just for the moment. Okay, so pen up, pen down. You heard a little click in there, that's a little servo moving that down, and it has moved down, as you would expect, moved up. So the instruction manual says, if I leave this alone for 30 seconds, that should pop back up all on its own. And that's because the paper is stationary, so we've got a felt tip pen stuck on top of it at the moment. Or if we had one, we'd have a felt tip pen stuck on the top of it and making a big blob, ink blob, and we don't want that. So let's just see if that pops up or not. And that's a function tested. There it is. Excellent. Yeah, so cool. So far, so good, surprisingly. Okay, so let's set the chart speed at 5. This button over here is saying internal or external control, so I'm going to go for internal. I'm going to go for millimeters per second. So if I've got everything else right, so I'll just set, there it is. If I've got everything else right, this should now move at 5 millimeters per second. 2, 4, 5, 6, 7, 8, 9, 10. So that has moved 5 centimeters. I'm going to time it a bit more accurately now. I should be able to return that back. Oh, really? You thought it was clever to provide that noise. So this is on its resistance range. Sticking in there as best I can. Okay, so it's got a meg ohm of input impedance, which is kind of what you'd expect from a instrument like this. Super. Right. Off the paper. Might add to my difficulties. So we obviously do not want a complicated. So I'm going to go for 1 hertz, if I can find it. Signal 4 volts. Peak to peak with an offset of 2 volts. I've got 10 volts as its full width. So I should be moving about 40% of the distance across it. Put pen down. Yeah, okay, so if I start this, so let's start the okay. So that isn't looking too good. It's trying to go for the wrong side. Turn it back on again. Okay, try the other way around. Okay, so that's definitely a bit dodgy because as I so that's 20 volts. But that wasn't behaving very well. In fact, there you go. It says 10 volts and it's working as though it's on a 20 volt range. That would appear to be pretty much, it's not totally hitting its mark. Okay. Let's see. Oh, gosh, this is very tight. I don't know quite how this is supposed to. Clip. There's a little lead clip that just goes into these holes here, and it's a little bit on the tight side, to be honest. This is the piece that's broken off on that side. So I just need a little box to put everything in so I don't lose it all. At the very least, a little tub jar for all the small bits. So that's out. I should be able to just lift this paper out. There you go. Very high tech plastic tube. Not bad. I mean, cleanliness gets a bit mucky. So you got one of those melting, disgusting things on the bottom there. Here we go, the big reveal. So I suppose the first thing that is kind of occurring to me is you seem to be short of an earth terminal. The second thing that's occurring to me is this plug looks reversible. I kind of just wonder whether or not it's been joined the wrong way around. So here's our board, and in truth there is really not a lot on it. So a large proportion of the board is unpopulated. I mean, this will be the same board for the 101 version and the 102 version, which has 2 pens. So essentially we just got, you know, instead of 1 amplifier section, we've got 2. Instead of 2, we've got 1. So there's only 1 lot populated. So you can see that this strip here, right along the front, is fully populated, and there's another matching strip along here, which is unpopulated. So that makes sense. Everything's fairly neat and tidy. Horrible square old routing, but you know, that's the way of things then. Internally, fairly clean. The capacitors look flat topped. No real issues. Let's drop there. So this is the input socket here and here. There's a little inductor on them, and this is the black input socket just here, and it's connected to the red wire. This is the red input socket, and it's connected to the blue wire. There's also a white wire in here, but following the cable he says, to there. By the time we get to the end, the wire has disappeared. Let's have a little look. Okay, so a little look. We've got a little relay. What have we got there? LTC N50. Is that a voltage reference? Can't remember off the top of my head. 7/4 logic. Op amp. Little thin film resistor jobby, and not a lot else. There's a big solenoid under here. Oh, a bit of power stuff on the left hand side. Back in this corner, but nothing really very exciting. I'm not going to bother to take it apart because it all looks okay. I'm going to keep sticking to my bench. But I mean, literally, we've just got, you know, there's a little motor over here. Little servo motor. There's a little power input board on the left there. There's a bit of rectification and stuff going on here. Somewhere back there might be a motor driver. Can't even see it, to be perfectly honest. Oh, you know, there's just nothing. They don't come much simpler. Let's see if I can persuade this to go back on. Okay, so this looks like it's one of those lucky repairs. I'm seriously really not going to do much to this. Well, a little bit, so I just want to clean up on the inside. This is just dilute isopropyl alcohol. Just to clean the worst of the rubbish off. It's just a bit easier to get at some of these things when there's no plastic case around. Okay, I have replaced the earth. So that's the riveted earth connection, just an eyelet. I think I like that better anyway because I really don't like these. It's an eyelet connected to a spade connecter. I can pull off a bit on the easy side in my opinion, everything seems to be connected well. It's generally pretty clean. I am just going to clean this bar here. I don't think it's supposed to have any lubrication. It doesn't seem to indicate so in the manual. Maintenance, page 20. No lubrication is necessary. Never lubricate the guide axis. Well, I'll not do that then. Okay, what I will do is just give it a quick wipe over with some alcohol, just to get rid of some of that roughness that's on it though, I think. Kind of feels like there's a lot of stuff in there. Still making a bit of noise, but not as bad now. So this one at the back, if I can get through there with that, I think I just want to get rid of that piece there. There's a little bit of roughness that's going to affect the pen as it goes by. The back bar is a little visor bar that back bar lifts, which causes the pen to go down. So that's actually, so just here is, hopefully you can see that, just here is a little lever going down from the solenoid with a little spring on it so it doesn't overdo itself. These paper paths can get a bit dusty. This is remarkably clean though. It's absolutely clear to me that someone has been in here doing stuff. And the reason it doesn't work, they put the plug back on the wrong way. Pretty sure on that anyway. We'll want some slightly more conclusive tests. This thing here is just coupling onto a multi-turn trimmer. Alright, +2. Oh, it's keyed anyway, that's not such a problem. Not the world's easiest. That's joyous, isn't it? Okay, just normal switch cleaner and lubricant. Unfortunately, so all I can do with this literally is squeeze a bit of cleaner into it and hope I can just work it backwards and forwards a few times, persuade it to clean up a shade. There's not a lot to do with this. I'll clean that other panel up in a second. Okay, cool, so all nice and clean. This is going to assemble very nicely. There's one last thing I'm going to check. This is of a certain age. I've looked at these capacitors and I'm happy. I'm not going to bother with those. But I do want to just take a peer around the side if I can and see what's going on with the mains input. It's a little awkward, everything's in the way. Oh, because of exactly what I feared I was going to see. So there's not much in the way of capacitors to speak of, but I'm going to try and get in there so you can see. Okay, so we're hand holding now, and we can see in there on the input suppression a nasty yellow capacitor. Now I'm not certain that that's a reefer. What I am certain of is I can see a crack in it. So that's the X2 capacitor across the mains. So if that goes, there'll be a lot of smoke. There's a MOV over there, that's alright. Now, I'm not sure I can persuade this camera to peer into the depth. No, we can't see it. But basically there are another two, as far as I can see, capacitors of this same style as this one, sitting further back, and they're not looking great. I want to replace those. I don't think it's safe to leave those in. There's a bit of muck down here as well, so I'll clear that out while I'm dealing with it. Okay, so just a quick update. I've just disconnected the top two little panels again, and the earths that I've just fixed. Just disconnected all that so I can get at this panel, but I still can't get at it. I'm hoping that the design of this is such that I can take out these 3 screws and the whole of this feed mechanism will lift out as one. I can see the board is actually designed to slide out vertically, I think. It seems to have some grooves cut for things like the actual IEC socket. This top section here lifts off. So, you know, in theory, if this lifts off, we should be able to get at what we need. Someone's obviously repaired that particular earth as well. I was actually looking on the internet for repair information on these, and funnily enough, I actually saw a photograph on a repair site of this machine. Now, I don't just mean this model, I mean this machine with this machine's serial number and everything. And they were boasting how they'd repaired it. I'm kind of guessing it was them who put it wrong in the first place, but you know, hey ho. Maybe I'm doing a disservice there. Truthfully, I'm, you know, just casting around a little bit in the dark here. Oh yeah, there we go. I think that will just lean forward. And get sufficiently out of the way. Okay, transformer. Sealed block. That makes life easy. So there's nothing back here. I mean, literally there's a tiny, well, I'm guessing that's probably just a little regulator. There's a direction switch. Those capacitors, they all relate to the little stepper motor in here, which drives the feed. And there's another little motor over here, little servo, which is, so that's just a plain motor. This side here we've got a sensor, and that's a lot. Nothing, I mean, it's just, how much do they charge for these things? Makes it exceptionally difficult. Oh. Yeah, there we go. Electronics is easy. Fingers crossed. Okay, main board, main power board. So we have a 0.06 microfarad X2, which is not as bad as I feared. Okay, here it is. Soldered all the new capacitors. Then it took a day to arrive, so that was nothing. And when I ordered them, I was very careful to choose capacitors that would physically fit as well as being, so here and here, these are physically the same size, actually just a tiny bit narrower than the capacitors that it's replacing. If you don't do that, you end up having to extend leads and things like that. The modern capacitors tend to be just a shade smaller. And I've taken the opportunity to just clean the top of the board with isopropyl alcohol at the same time. And there's the bottom, also cleaned up, all the flux removed, all the residue that was on there from before. All I'm going to do now is reassemble everything, double check to make sure there are no calibration points on the main board, and I will clean the different components as I put it back together. So I've already, for example, cleaned the top cover because that came off as a single piece of plastic. Just cleaned it all down, and the reason I do it as I go instead of when I've finished is because you can get at all the small holes, all the small spaces that are awkward when it's assembled. It's a lot easier when it's in pieces. I'll be back to you soon. Okay, so it's all been reassembled, and it's up and running. It's nice and clean. Hopefully we can see that here, all the sticker residue gone, all the dust gone. The pen is running backwards and forwards nicely. Paper's advancing. Everything's just fine, in fact. Looks like a new one. So we have done a few tests on this as well. We've been through all of both the voltage ranges and the speed of the paper advance. There's also a setting on it which is a voltage offset. So for example, on the 10 volt range, which is normally 0 to 10 volt, you can switch the offset to +1, and it does a 10 to 20 volt range, and so on. The next thing was to actually double check and make sure everything was safe. So the main thing there is to check the mains cable, visual check the fuse, actually check it's a BS plug, not a fake. Plug that into the PAT tester, carried out an edition 5 test on it, so that's all the things like the polarity of the connectors, the impedance of the earth cable, and then secondly plugging that into the machine and running electrical tests on the machine itself. So for example, testing the earth impedance between the touchable metal parts on the machine and the actual earth pin on the plug, and things like leakage, the insulation itself. So all of that's passed, not a problem at all. It's all been labelled up, and I think I'm probably going to sell this one on. So that's it for this repair. Not the most complicated repair, it was more of a refurbishment, but hopefully you got something from it. If you liked it, please don't forget to click the like button. Also subscribe, that really helps, and feel free to comment below. That's it for this time. See you soon, and take care.